So now I will show you how to run Chrysalis. So Chrysalis can be found in this folder here, and the version we want to use is Chrysalis use this version. This is in the same folder, is also where we have the generate compensation matrix script, which we use for making our compensation matrix. So what you'll want to click on is this Chrysalis application. It takes a minute to open up, so I've already opened it up, and so when it fully loads, this is what the starting screen looks like. And really straightforward user interface in that there's the input folder, so you click this and you select the folder that contains all the files you want to analyze. So in our case, I've generated an analysis example folder with our images, so let's select that. For the output, let's use the same folder. So the analysis example images folder will be the output, and so that's set. So you can click on this and type in the path for the folder, or you can use these buttons to find it. Now, if you want to do the spectral mixing on your images, you have to also select the compensation matrix. So we do want to perform that function, so let's go to compensation matrix. Let's go to our folder, let's go to our images folder and select this compensation matrix. And so the compensation matrix will have that .stm ending, so let's select that. Okay, so we have now selected our images, where they're going to be saved when they're processed, and our compensation matrix. And one key thing is that here we need to type in what our images file extension is. So in our case it's .lif, so the Leica file, so that's the default, and that's what we're going to have. But for example, if you're coming from Nikon, that might be .nd2. Okay, now in this example we are looking at confocal images, so we'll want to do the 3D image, and then we can select what kind of image processing we want to do. So we have 4 different options. We are interested in doing the spectral mixing, and if we do spectral mixing, rescaling the data should pretty much always be selected. So when spectral mixing occurs, data needs to be changed and rescaled. But each channel will get scaled differently, so not everything gets like multiplied by 10. So then if we click rescale data, when the rescaling occurs, a file will actually be generated with how much each channel was rescaled, and this is really useful for actually doing the quantification in Imaris, as I will show you later. Now, 2 other settings that we can choose are this new channel setting and the merge all images in each image setting. What this selection here means is that if your image file, if your Leica file, let's say, has 10 images from the same spleen, and you want to analyze all 10 of those together as one compiled image, then you can select this, and so those 10 images will become one large image when this processed version is saved. And so, and they're stacked one after the other in the z-plane, so you maintain your x and y, and you just get a very, very large image in the z-axis with all 10 stacked one after the other. So I found this really useful because with confocal microscopy, especially high-resolution confocal microscopy, you're not going to be able to tile large images in a reasonable amount of time, so you might select specific portions of the tissue to image. And then if you do that but want to analyze it as if it were a stitched together image, then you can use this to do that. The other cool feature is this new channel feature. So this allows us to create a new channel from existing channels. So we want to make one new channel. So here in the number new channels, you put the number, and so then in the select new channel, you'll have 1. If we want to make 3 new channels, then you'll have 3 here, And what this allows you to do is go between the three different channels and edit their settings for each channel. And so then you have to list how many channels are there within the image. So this is a 10 color confocal microscopy image, so we'll put 10. And now you can see that there are a base channel, we can select one of the 10, then include channels, we can select one of the 10, and then the exclude channel, we can select one of the 10. So the channel we want to make is a dendritic cell channel. We're going to identify dendritic cells as being CD11C and MAC class 2 positive. So that's channel 7 and 8 for us. So you can select the two channels by doing shift and then clicking. So click 7, press shift, and then left click on 8, or by using control to select as many channels as you want. And so let's say if we accidentally selected 4, we can control click 4 again to unselect it. So with the DCs, we're including CD11C and MAC class 2, but then we can also exclude channels for this new channel. So we do not want pixels associated with macrophages, which is F480, or B cells with B220, or the TCR transgenic cells we transferred, labeled with CD45.2. Additionally, channel 9 is CD3, so we're looking for DCs, not T cells, so we want to exclude that voxels with high signal there. And so these are our inclusion and exclusion criteria for the new channel. So what this means is that any voxels with strong signals in channels 7 and 8, but weak signal in channels 1, 2, 6, and 9 will be in this new this new channel. And now selecting those include and exclude channels, that basically gives us a plus minus image without any values. So for all of the voxels, which are the 3D pixels that are included in this new channel, we need to give them a value, and so we select one of the existing channels to give them a value. For the DCs, I like to use CD11C, which in this panel is channel 8. So what this means again is that only the voxels that are bright for CD11C and MAC class 2 and dim for F480, B220, CD3, and CD45.2 will be included in this new channel, and the signal intensity for those included voxels will be the CD11C channel. And so if we wanted to make multiple new channels, here we can select 2 and select different settings like this for channel 2, and then if we wanted to go back and edit channel 1, we just select channel 1 there. But like I said, we're actually only interested in making this single new channel, so I did that to actually reset. So let's just quickly re-select those options, and we're good to go. Okay, and so now we selected that we are going to spectrum mix. We selected that we are going to make this new channel, this new DC channel. We're rescaling data. Anytime you spectrum mix, you should be rescaling the data. And then we have 3 images that we want to merge together because they're all from the same spleen. So we're going to select that final step, and then we just click run. And so at this point, this progress window comes up, and so our files will get loaded in, they will get processed, and then they will be saved where we specified. And so this process can take a bit of time if you have large images. So when the image processing is finished, this window will pop up, processing finished, and so we can click OK. And then if we wanted to analyze a different set of images in a different manner, we can go and select that relevant folder and change all the stuff around. Now, I should also mention that Chrysalis does not just work for 3D images, so epifluorescent or confocal microscopy images. It also works for two-photon microscopy movies. And so let me just show you that functionality. So if we go to movies, we still have spectral mixing available to us. We still have new channels that we can make, and we still can rescale the data. But there are a couple other features. So one is save movies as AVI file. So what this will do is for each movie, it'll generate this AVI file. This is really useful for if you want to preview the movies before analyzing them, because you want to find images depicting tissue, healthy tissue. With two-photon microscopy, you might be taking many different images in one day, but some of those movies will look better than others, and some of them, for example, will have unhealthy tissue because the tissue prep, for example, has been sitting on the microscope for a while. Due to that kind of variability in tissue quality, it's important to find the best movies before actually doing the in-depth analysis. And so if you click this save movie as AVI file, it'll save the AVI file, and we actually also made it so that you can pick what colors to use for the AVI file. So our two-photon microscopy system here, you can have up to 4 different channels, and so then for each channel you can pick which color to make it. So here, for example, I'm picking 4 channels, and I selected 4 different colors, one for each channel. The other feature is save movie as big data viewer file. So this is good for downstream analysis. So if you do perform spectral mixing, if you make a new channel, if you rescale the data, then you will want to save the movie as a big data viewer file so that it can be opened up in Imaris for further analysis. But we made this as a feature because you might just want to get those AVI files to quickly screen through your movies and see which ones are actually worth analyzing. And so you can perform just this AVI file exporting just to find the best movies, and then do the actual full image processing steps on only the movies you're interested in. So that's using Chrysalis, and so let's look at what it generated. So if we go to our compensation folder, now there's this .h5 file, there's the scale factors as a text document, and then there's this XML document that is more information about these guys. So those are the files that are generated by this process, these 3 files. And so at this point, we're ready to go into Imaris.